In this video, we're going to look at another functional block within the floating point unit. Now, previously, we've looked at the adder subtractor, the multiplier, the square root, and the division. Now, you'll notice we've got these two blocks here, and in fact, this chordic block has just appeared. Now, before we go through the chordic block, we're going to talk through this float to integer conversion. Now, why do we need this block? Well, if we want to plot a floating point number on our screen, we're going to have to change it to an integer value. So for example, if we want to plot the position 89.77, then we're going to have to change that to an integer value. So for example, 89.77 will round up to 90. Or if it's 89.2, it'll round down to 89. So we need a function here that's going to round up or down a floating point unit to the nearest integer. And the value that we generate from these for both a value of x and a value of y will then get passed out of the floating point unit, and we can use these values in order to plot a value onto the screen. So let's drop into this float to integer conversion and we'll see how it works. Now there's going to be two levels of hierarchy for this, so let's drop into the first one. Now I'll make this a little bit bigger. Okay, so this level is relatively straightforward. We've got two units here, which in effect are the float to integer, or we could call it float to decimal if you want, but it's really an integer value. So the float to integer block here and a float to integer block here. Now, the interesting section's actually within these blocks, okay? So we'll go in and have a look at that just in a minute. But what we have here on the top level is an input x and an input y, and these are feeding into these blocks. And of course, the output is going to come out here, and it should be the integer version of this value of y. Okay, so we're going to round up if it's 0.5 and above, and we will round down if it's 0 to 0.4. And the values are going to come out here and they're going to come out here. If we look at the inputs here, we can see that we have 0 for x and 0 for y. So we want to plot a point 0, 0. Now the screen that we're going to use is going to be a value of 0 to 255 in the x direction and 0 to 255 in the y direction. But the point 0, 0 on that screen is going to be the top left hand corner. Now we don't want the top left hand corner to be 0, 0. We want the centre of the screen to be 0, 0. So at the centre of the screen we're going to be able to plot points vertically upwards, which are going to be 128 points, and vertically downwards 128 points. And then we're going to have 128 points to the right and 128 points to the left. So what we're going to do here is we're going to reposition the 0 so that it sits at the centre of the screen. So we can do that with these add and subtract blocks. So if we take the x value, for instance, the value of 0, we don't want it to be at the left hand edge, we want it to be the centre. So we're going to have to add this number 7f onto it. Okay, so in effect we're adding 127 onto it. So remember, we say 127 because we're actually including the point 0 as well. So in effect that becomes the 128th point. So that's going to take us to the centre in terms of the x values. Now in order to get to the centre in terms of the y values, what we can do is we can take the y value away from our 127 and we get this point here. So that means that the centre of the screen is going to be along 127 and down 127. But remember, it's actually 128 because we're counting 0 as a point as well. So this gives us the point at the centre of the screen. Okay, so we're just shifting the 0th point to the centre. Now once we've positioned the 0 point at the centre for both x and y, we're going to have to shift the y position 8 bits to the left, because we're going to have an output which is going to have the most significant 8 bits representing the y position and the least significant 8 bits representing the x position. So it means that we're going to have to shift the y position to the left by 8 bits in order to position it properly within the 16 bits. So we do that here with this shifter. And then we add both of them together and we get our final output here. And you can see here the final output is the value 7F, 7F, which is going to be the centre of the screen. But we have one other little section here at the bottom. Now, if we try to plot a point that is out with the plus minus 128x, plus minus 128 in the y direction, then there's a potential that one of those points will possibly get plotted, and it will be plotted obviously as an errant point somewhere on that screen, and we don't want that to happen. So we just want to make sure that we cannot plot any points that are out with those limits, and that's what this little section does here. Now we're not interested in whether the values for x and y are positive or negative, so we're only looking at the first 15 bits of the floating point number. And what we can do is we can make a comparison with this number here, 57F8. So let's have a look and we'll see what 57F8 is. So we can pop the 57F8, so 0 cross 57F8 into our little conversion tool, and you can see it's the number 127.5. So we're checking to see whether making sure that the number is less than 127.5. Now, if it was greater than or equal to 127.5, then it would be rounded up to 128. And including the 0, in effect, we would be looking at position 129, which is out with the screen. So it means that as long as both of the numbers are within the correct range, then we'll get a high output here, and this high output here will choose just the output from our circuit, and we will get the value plotted. If it doesn't, then it will give us the value 0000, and we'll get just a little plot in the top left hand corner of the screen, and that'll tell us that there are errant points but they've not been plotted onto the screen. So that's the top level of the circuit. In the next video we will look at the actual float to integer conversion. So we're going to look at this circuit here. So that's all for this video. Thank you for listening. I'll get you on the next video. Goodbye.